Okay, so we are here on a new project, and I can see on the left that I have different analysis systems as well as some component systems. So I'm gonna look up for transient thermal because that's the kind of problem that I want to solve. So I'm gonna drag this into my workbench and I will place it here. And I can decide to give it a name if I want to. So let's call it 1D unsteady heat transfer project. You can call it like that. And the first thing I can do is create the geometry. But before I do that, I would like to go into engineering data because I want to create a new kind of material. We know that we are solving this problem with non-dimensional equations, boundary conditions, and initial conditions. So I want to make sure that when I compare whatever I get from the software with my solution, they are equivalent. So in order to do that, I will double click on engineering data or simply edit. So this is gonna open a new window. And in this window, I see that here where it says engineering data, I have by default structural steel. Now I can create a new material. I can add it. For instance, if I want to add aluminum, what I would have to do is simply go into engineering data sources. So they'll load the different materials that are predefined in ANSYS. And I need to move this. I can come to general materials. So within general materials, I'm pretty sure that I will find the most common metals, thermal materials. I will see that I got aluminum, brass. Yeah, here, aluminum. So I got aluminum. And if I want to add aluminum to my project so it's available, the only thing that I have to do is click here on this plus symbol. So once I do this, now I will be able to see this icon of a book, and it means that now it's part of my project. Or I can also create a new material. So to create a new material, I come again to my engineering data source, and I have this option where it says click here to add a new material. So I'm going to create a new material and I'm going to call it my own material. Enter. Now this, my material, doesn't have anything in it. And I know from this presentation that I shared a few minutes ago that the kind of properties that I need are these: thermal conductivity, density, and heat capacity. So I can define with that my thermal diffusivity, which I will make equal to 1. So my governing equation becomes my non-dimensional governing equation. So let's say that the material has density 1000 and that the heat capacity is equal to 1000, and my thermal conductivity then will have to be equal to 1 million. So when I calculate thermal diffusivity, it'll be equal to 1. And as long as the units are consistent, I should be fine. So here, my material, first thing I will add is density. I have to define density. So I will come to density, I will click on density, and I will drag it and place it onto my material like this. So once I do that, then I can define my density. The units are kilograms per cubic meter. So I will say that this is equal to 1000. And here also I have a chart or a graph where it shows that the density is equal to 1000 or equal 1 times 10 to the 3,000. And it's constant for all temperature. So I have temperature here is 0, 0.5, and it can go even up to 100,000, whatever that may be, but it's constant. Now let's see what else we can add. We have to go to thermal properties. I have isotropic thermal conductivity. Yes, I will include this into my material, and this isotropic thermal conductivity will be equal to 123, 123, 1 million. And finally, I need to define the heat capacity. So my heat capacity will also come onto my material, and this will be equal to 1000. The units are consistent, so my final thermal diffusivity will be equal 1, and this is a new material that I have created. Now, do these properties depend on temperature? Some, yes. So I could potentially also create an expression for making them dependent of temperature, but for this problem, I will simply consider that they are constant, that they don't change with respect to temperature. All right, so now that this is done, I can come back to my project. And here my project, I will come to geometry.